right, let's take the derivative of this. To take the derivative, we'll call it y prime. This is a product right there. There's a function and another function. And this, even though it's a product, that's not really a function of x because it's a coefficient. So you actually don't have to do the product rule for that second one. But you do have to use the chain rule because there's a function inside a function. Here we have to use the product rule, but also we have to use the chain rule because we have a function inside a function. So the product rule says the derivative of the first, which is 1, times the second, plus the derivative of the second, which is 4e to the 4x, times the first. Plus the derivative of this would just be 5 times e to the 6x times the derivative of that function, which is 6. So cleaning this up, we get e to the 4x plus, it's usually good to write the 4 and the x in front of that e, 4x times e to the 4x plus, let's take those and put that to the front, which would be 30 e to the 6x. And let's see if we can do anything else with that. You might be able to if you really wanted to factor out an e to the 4x, you could, but I think this is probably sufficient. The answer there is probably sufficient. So again, maybe you were confused by what I did here, so let me go backward and explain that again. The derivative of e to the 4x. There's a rule that says that the derivative of e to the u with respect to x is just e to the u times the derivative of u with respect to x. So you take the whole function and just basically rewrite it, and then you multiply it by the derivative of that, of the u up there, which in this case is 4. So that's why, then y prime would be 4e to the 4x. And that's what I did there.